Hello everyone, my name is Atharva Mangesh Jadhav. I am currently intern at Emertxe Information Technology. I am third year ENTC student from MET Institute of Engineering, Nasik. First of all, thanks to Emerging Information Technology for this internship. It is a 4-week internship of embedded system. In this internship, we build a microwave oven project on MPLABX ID software and simulate in PIC So this is the PPD of project presentation of microwave oven project. So here are contents of PPT. First is introduction, then basic embedded system and programming, which contains a definition. Then microcontroller and microprocessor, which contains a block diagrams, difference between microcontroller and microprocessor. Then which softwares which we are use, and then components, peripherals. Then what is microwave oven, which is our project. Then actual simulation part, which is on PIC then advantages, disadvantages, application, conclusion, and future scopes. First is an introduction. So this is a embedded system internship. This is a 4-week internship. In this internship, I build a project of microwave oven. The microwave oven project is an embedded system application which is designed to control and simulate the basic operation of microwave oven. The project demonstrates how a PIC microcontroller can be programmed to manage the function like cooking time, grill time, handling user inputs through a keypad. The firmware is developed using MPLABX IDE, utilizing the X8 compiler and simulate in a PIC SimLab. Before going into a real-world implementation, this project highlights the importance of embedded system in modern kitchen appliances, improving safety, efficiency, automation. So there is a basic definition of embedded system is a which is a specialized computing system which performs dedicated functions within a larger system. That means embedded system is a combination of hardware and software. So embedded system role in micro oven is controls the user inputs, manages cooking, grill operations, and handles the timing operation. So key features of embedded systems are real-time processing, power efficiency, integration with hardware components, and etc. In this project, we use a microcontroller PIC16F877A, which is programmed to handle display and then a keypad input. So examples of embedded system are automatic washing machine, home automation system, micro oven, which is our project, then smartwatches, smartphones, and there are different examples of embedded system. So in this project we use a C programming language, and we use C programming language to simulate the project and write the code in MPLABX IDE software. So here is a definition of embedded C, which is a specialized programming language used for writing software which runs on embedded system. So used in a micro own project. Program in C language using a MPLABX IDE and compile in a X8 compiler, which handles the real-time processing for micro operation, uses interrupts and timers ISR for controlling cooking, grilling, convection time. So why we use a C programming? Because it has some advantages like efficiency and performance, that means direct hardware access and optimized execution. Portability, that means works across different microcontrollers. Memory optimization, fits within limited RAM ROM, and then real-time processing, which is very important, supports interrupts and processing timing, industry standard, which is also important, widely used with a strong community support. So we use a C programming. So during this internship, we learn a different basic topics regarding the programming. So there is a history of C language, which is developed by Dennis Rich in 1972 at Bell Laboratories of AT&T Labs. It was developed as a system programming language to write the Unix operating system. So in this internship, we learn about data types, printf, scanf, if, else, etc. In these data types, there are different data types like integer, character, floating, double, etc. Then a printf, which is used to print formatted output to standard output. Then scanf, which is used to read user input from console. Then if else, switch case, which is like as if else, if which is used to decide whether certain statement or block of statement will be executed or not. Then if else, that means if statement alone tells us that if condition is true, then it will execute a block of statement, and if condition is false, then it will not be executed. Then a switch case is similar to if else. That means it is alternative like if else, if ladder that can be used to execute the conditional code. That means it is one type of conditional code. Then while loop, do while loop. The while loop is used when you don't know advance how many times you want to execute the block of code. That means if the specified condition is true, then it continuously executed. Then do while loop is guarantees that block of code will executed at least once before checking the condition. That means if before checking the condition, the at least one time the block of code will be executed. Then for loop it used when you know in advance how many times you want to execute the block of code. That means specified condition in the for loop, and the block of code will be executed. Then operators, array, pointer, strings are very important in programming. Operators are symbols which represent operations to be performed on one or more operands. Then array is one of the most important in programming, which is simplest and fastest way of storing multiple values under a single name. Then pointer is a variable which stores the memory address of another variable. Then string is a sequence of characters terminated with a null character and stored as an array of characters. Then preprocessor are program that process the source code before compilation. So here are topics which are very important in programming. Then after this we learn about different peripherals programming, such as LED programming, switches. That means if we press the switch, then LED is blinking. Then programming for level and edge triggering, programming for matrix keypad, programming for interrupts, programming for timers, programming for CLCD, etc. Then we learn basics of microcontroller and microprocessor. That means microcontroller is a single integrated circuit containing all necessary components like CPU, memory, input output ports to perform specific tasks within an embedded system. Microcontroller is a self-contained computer on a chip. So we use PIC16F877, a microcontroller. Then microprocessor is a standalone processing unit, CPU, which requires external memory and peripherals to function, making it better suited for more complex computing tasks. So microprocessor is just like a brain which needs additional components to operate. So here is basic block diagrams of microcontroller and microprocessor. So here is a difference between microcontroller and microprocessor, in which all components will be in a single chip in the microcontroller, and all components are assembled separately in microprocessor. Microcontroller is a specialized form of microprocessor, and microprocessor is a general purpose, which is designed for general purpose. Microcontroller is cost effective and which is self sufficient, and microprocessor is it is a silicon chip. So microcontroller power consumption is low, and microprocessor is opposite, that is power consumption is high. Microcontroller contains CPU, RAM, ROM, register, timers, and input output ports. And in a microprocessor requires combination of timers, controllers, and memory chips. Microcontroller size is smaller, and microprocessor size is larger. Microcontroller uses hybrid architecture, and other side microprocessor uses a von Neumann architecture. Microcontrollers system cost is low, and microprocessor system cost is high. So here is a basic difference between microprocessor and microcontroller. So in this overall project, we use software for programming, which is MPLAB IDE, and for compilation we use a X8 compiler, and for the simulation, overall simulation is going on PIC and we use a PIC16F877, a microcontroller. Then matrix keypad, which is built in PIC and 16S to 4L CLCD, which is on the PIC timers, ISR. So here are the software and components which we are used. So here is the view of PLABX IDE software, you can see. So also this is the view of PIC This is the simulator of our project. So here are the peripherals. First is CLCD, which is character liquid crystal display. It is used for displaying purpose. There are two types of CLCD, 16:2 and 16:4. Both are in PixSimLab. It displays ASCII characters and special characters. There are two types of modes in CLCD, 4-bit and 8-bit mode. So this is CLCD, and then the matrix keypad. Matrix keypad is used for the user input. That means it allows the user to input. It is a 4 by 4 matrix keypad. It provides a start, stop, and present function keys. It is integration in the PixSimLab, which is connected to the PIC16.77 microcontroller by using general purpose input output pins. So key press detection handles using row column scanning method. Programs the embedded C to read input and process commands. That means user inputs by using matrix keypad. Then timers are very crucial components in embedded system, which is used for time tracking, event scheduling, delay generation. So timer role in micro oven is very important. It controls cooking time and manages countdown functionality, generates accurate time delays and schedules operation, ensures safe and precise execution of cooking cycles. So timers are very important. So a timer implementation in this project is timer module in the PIC microcontroller to track the time, interrupts trigger actions when the present time elapse. It ensures the accurate cooking duration and alerts the user when completed. So timer is very important. Then ISR, which stands for interrupt service routine. In embedded system, ISR is a software function which responds to interrupts from hardware, a block of code that handles interrupt in the computer system. It is triggered when timer is overflow. When the timer is overflow, then it is triggered. Then handles the cooking time decrement and display updates. It displays the updates. It ensures the smooth operation without logging the other tasks. So ISR very important. So here is a basic pin diagram of PIC16F877 microcontroller. It has 40 pins. So you can see. So here is a peripheral diagram of PIC16F877. It has a ADC, analog to digital converter, GPIO, general purpose input output pins, then LM35, which is a temperature sensor, then I2C, RTC, EEPROM, which is electrically erasable programmable read only memory, then peripherals are LEDs, buzzer, keypad, RS232, then CLCD. Then here is a basic block diagram of PIC16F877 microcontroller. So here are a port A, B, C, D, E. There are input output ports. Then 3 timers, timer 0, timer 1 and timer 2. Then it has a inbuilt 10-bit analog to digital converter, EEPROM, USART. Then data bus. Then there is MUX is there. Then flash program memory, which is ROM. Then there are different types of then instruction decoder, timing generation. So here is a basic block diagram of microcontroller. ALU is there, W register is there. Then this is our actual project for microwave oven. Microwave oven works by using microwaves to heat the food. The microwaves cause water molecules in food to vibrate, which creates the heat. This process is called as dielectric heating. So how microwave ovens works? The electron tube is called as magnetron, which produce microwaves inside the oven. The microwave bounce around inside the oven metal interior. The microwave are absorbed by food. The water molecules in food are vibrate, which creates the heat. So different safety tips which we needed. So don't put vacuum sealed packages in the microwave oven. Don't cook eggs in the shells in the microwave. Don't run empty microwave. um, then use microwave safe cookware. So there are heating tips are there. Microwave heating is more efficient for liquid water than frozen water. Then fats and oils absorb microwave and rise in temperature faster than water. So in this project we are going to implement, there are 4 modes: micro mode, grill mode, convection mode and start mode. So there are CLCD displays there. First is micro mode, then second is grill mode, then third is convection mode, and fourth is start mode. So first is micro mode. So first is displays on a CLCD, which is max power of 900 watt. So micro mode in micro oven project refers to the basic micro heating functionality which uses electromagnetic waves for cooking and heating the food. In this mode, the magnetron generates the microwave which cause water molecules in the food to vibrate, producing heat. Micro mode is ideal for reheating, defrosting, and basic cooking tasks. The power level and time can be adjusted based on the type of food being prepared. So this is the micro mode. Then grill mode is there. Grill mode in micro oven project enables the grilling and browning of food using a heating element. Unlike micro mode, which uses microwaves to heat the food internally, grill mode applies direct radiant heat to the surface, creating a crispy texture. This mode is ideal for grilling meats, vegetables, and toasting breads and etc. Some micro ovens are also allows the combination of micro and grill modes for faster and more efficient cooking. This is very important. So there is a convection mode. Convection mode in micro oven project utilizes a fan and a heating element to circulate air evenly inside the oven. This mode allows for baking, roasting, and crisping food similar to the traditional oven. Unlike micro mode, which heats the food using microwave, convection mode ensures uniform cooking by maintaining a consistent temperature. Some ovens also support a combination of convection and microwave modes for faster and more efficient cooking. So this is the convection mode. Then fourth mode is smart start mode. Start mode in this project which initiates the cooking or heating process after selecting the desired mode, the power level and time. When the start button is pressed, the micro oven activates the chosen cooking mechanism such as micro mode, grill mode or convection mode. It ensures that the oven begins functioning according to the present setting, enabling efficient and controlling cooking. So there are four modes. So after this we see the project simulation. So this is software which is MPLAB IDE. Here is header files are there, then source files are there. So actual program part is in the editor window. Here are codes. If we build the project, just a second. Because of network issue. So if we clean and build, then clean is successful. So after this we are going into PixSimLab. So board is a Peak Genius board, and microcontroller is Peak 16F877 microcontroller. If we load the if we load before loading the X file, we check the frequency which is 20 megahertz, and LCD is 16:4. If we load the hex file, then powering on microwave oven. First is micro mode, grill mode, convection mode and start mode. If we press 1, then power is 900 watt. If we set the time as 10 seconds, and if we enter, then it is started. If we I press 5, then it will pause. If I press 4, then it will start. If then after 5 seconds it will stop. Okay, and then if I press 2, then grill mode again for 10 seconds and enter, then enter, then also started. If I press 5, then pause, then start. If I press 6, then in the menu mode. If I press 3, then convection mode. If I set the temperature as 15, then preheating in 60 seconds. We'll waiting for 20 seconds. So it is completed. If we reset, then again in the menu screen. So if I press 4, then timing started 30 seconds. If I press 5, then it is pause, and if I press 4, it is start, resume. If I press 6, then it is the menu screen. So here is a overall simulation of microwave oven project. Just a second. So our simulation is completed. So there are different advantages and disadvantages. Such advantages such as easy to clean, then quick reheating, then cooking programs and then a user interface and precise control over the cooking temperature. Then different disadvantages such it is a not versatile, food poisoning, which is disadvantage. Then cost is very high. Then if you use a microwave, you need to microwave proof containers. If you use a normal container, then containers and the microwave can get damaged. So these are the disadvantages. Then applications are the home applications, which is used in the household microwave ovens for the automated cookings. Then industrial use, then implemented in a food processing unit for precision eating. Then the medical industry, for the sterilization of medical tools. Then automotive sector, which is applied in the vehicle heating and defrosting systems. Then in the field of aerospace, which is integrated into a space food heating system. Then after the conclusion is this project successfully implements a microwave oven control system by using an embedded microcontroller. The use of timers, ISR and safety mechanisms ensures a reliable operation, and the simulation epic sim lab validates system behavior before real world deployment. So this is the conclusion of our project. So future scopes are IoT integration, touchscreen interface, AI based cooking modes, voice control, energy efficient improvements. So there are a few different future scopes are there. So this is the overall about the project of microwave oven. So thank you, especially for emerging information technology, for this beautiful opportunity for internship. So I am very enjoyable in this 4 weeks of internship. Thank you.